Physics is a multi-representation subject. So in order to describe something precisely, sometimes sentences and words are not enough. So we will need equations or graphing to help us to deliver the ideas. So here I wanna briefly talk about how to make a proper graph when you wanna talk about physics. So let's say we wanna describe the position of a person over time. So this person is walking to the right with 5 meters per second. So 5 meters per second is its speed. So instead of just stating the fact that the person is walking at a constant speed 5 meters per second to the right, we can actually using the equation to talk about his behavior. It's something you will learn next week in kinematics. So we will know the position is 5 meters per second times the time. So at 0 second, this person will be at position 0. After 1 second, the person will walk 5 meters because it's 5 times 1, which is 5 meters. And after 2 seconds, this person will be at the position of 10 meters. So this is the power of using equations to describe like a motion. It's very elegant. Another way to talk about the motion is we call it graphing. It's also a very powerful tool, and we will use it a lot because it's very easy to visualize the motion from a graph. So let me show you how to do the graphing of this motion. To do the graphing, you need to have an x and a y axis. So usually if I want to know the position at a certain time, then I will put that position in the y axis and put the time in the x axis, in the horizontal axis. And then I can start to see, I know at 0 second, this person should be at the position 0. After 1 second, this person would be at 5 meters. And at 2 seconds, after 2 seconds, the person would be at 10 meters. So now I can connect all the trajectory, like the dots together, and you will get a linear line. So when you present this picture, like this graphing to another person, you look at this and he can immediately to picture that, oh, this picture is describing a motion of a constant speed. So when I am drawing this graph, there are a few things that I want to look at. So for example, you want to, for example, this is important one. You need to indicate the axis to tell people what is on the x-axis, what's on the vertical axis, and what's on the horizontal axis. You need to have this two information in order that people know what you are trying to talk about. And then you also need to indicate the origin point or give it some numbers, some reference points so people can roughly know, at where you are at a specific time. And eventually, because when you do the graphing, you want to connect all the dots together. You want to connect all the events together. So eventually, it will be a smooth curve. In this case, it's a linear line. Some people will add an arrow here. Don't do that. We don't have any arrow here. Okay. If you put an arrow here, it means something different. So don't put an arrow here. All right, so you can see this, the circles which I highlighted are something that I'm looking for a good graph. A few common graphing you will see in these courses is kind of something like, for example, the first one we call it a constant graph. Constant graph means the subject is not moving at all. Like it stays the same all the time. So this is what we call constant. Some people will kind of understand constant as 0, which is not true. Constant just means it stays as a constant. It doesn't mean it's 0. Linear proportionality. This is the graph that we saw like a second ago. Quadratic. Quadratic is a very common graph that you will see in projectile motion. So you will see that a lot. Inversely proportionality is a graph which looks something like this. It means if as the x get bigger, your y will get smaller. So this proportionality also show up a lot in physics relationship. So this is just a very brief overview about how to make a proper graph and the name of some common graphings that you will see in this courses. And later on, as you use more graphing, in different physics subjects, you will get used to it.